image of a point in a line. We are having a point and we have to find exactly the mirror image of A, that is B, for on this line, and line acts as a mirror. Now let x minus x1 upon A is equal to y minus y1 upon B is equal to z minus z1 upon C. Let this be first of all equation 1. Okay. Be a equation of a line, be an equation of a given line, and point A with coordinates p, q, r is a given point in a space. Now step 1. Let B, point B with coordinates alpha, beta, gamma, let point B with coordinates alpha, beta, gamma be the mirror image of point A in line 1. We have already mentioned that this is line 1. Let capital B with coordinates alpha, beta, gamma be the mirror image of a point A in line 1. Then direction ratios of AB are alpha minus P, beta minus Q, gamma minus R. Now these are the direction ratios. Step 2. AB is perpendicular to given line. Therefore, A with alpha minus P plus B with beta minus Q plus C with is equal to 0. Let this be equation number 2. Step 3. Let M be the midpoint of AB. Coordinates of M are, now coordinates of M alpha plus P, now alpha plus P upon 2, beta plus Q upon 2 and gamma plus R upon 2. Step 4. from equation 1 and step 3, we get from equation 1 is this one, and step 3 and this one. Now what we are getting? Alpha plus p upon 2 minus x1 upon a is equal to beta plus q upon 2 minus y1 upon b is equal to plus r upon 2 minus z1 upon c is equal to lambda. Okay. Now step 5th, obtain value of alpha, beta, gamma in terms of lambda, solving step 4. Step 6, obtain value of lambda by substituting values of alpha, beta, gamma in equation 2 of step 2. Step 7, put value of lambda in step 5 to get B alpha, beta, gamma. So we have to follow all